Okay. Good morning, everyone. This is the setup for heat transfer by natural convection. Okay. The first question, when we will try to understand this experiment, that is heat transfer by natural convection, we have to know what is natural convection. Natural convection means convection is happening naturally. That means no external means is applied. That means the airflow is not happening due to because of some fan, and for that, or blower, and for that you can see the heat transfer section where we will study the heat transfer section, that is this vertical pipe is enclosed in this box so that no disturbance from the outside air is happening. Okay, if there is a disturbance from the outside air, that means the air is flowing from external means, that means there will be a heat transfer which will be happening because of forced convection. Okay, now in this experiment we will find out what is the heat transfer coefficient of this vertical pipe. For that you will see there are many thermocouples like this one, all total 7 thermocouples are arranged, which will give the temperature reading at different section of this vertical pipe. Now, before switching on, before starting this experiment, we have to ensure all the main switches are switched off. Now, before starting this, I ensured all the switches were off. Then I switched on the main switch. After switching on the main switch, you can see this red this light is on. That means mains power is coming to it. But this our indicator, that is switch on and off indicator, is off. Now I will switch on this button. Now you have to ensure that this dimer state is in 0 position. That means to this extreme left position. Now what I have to do, I have to rotate this dimer state and gradually increase the voltage. You can see this reading is gradually increasing, that is the voltage reading is gradually increasing. So let us say I have fixed the voltage to 80 volt. So simultaneously you have to take the reading of voltage and ampere. This is the indicator for current. Okay, you have to take a note down of this. Then you have to wait for at least 1.5 hours. So after 1.5 hours, what you have to do is you have to take the temperature reading. This indicator gives us the temperature reading, and you can see this is the small switch here. This 4 written here. Then if I click this, it is 3. Then it is 2. That means this is the temperature reading of thermocouple 2. If I click it here, then this is the temperature reading of thermocouple 3. If I click it again here, this is the reading of thermocouple 4. Likewise, you have to take all the thermocouple readings after 1.5 hours. Now, after 1.5 hours, what we have to do, after taking the first reading, we have to wait for 10 minutes. Then again, we have to take the same thermocouple readings again. Likewise, we have to take consecutive readings 10 minutes after 10 minutes, so that we will achieve a set of values or observation where we will see that the values taken 10 minutes before in the thermocouples will be almost similar to the values taken 10 minutes after. That means 2 consecutive observations will be almost be equal. That means we will, at that moment, we can ensure that the steady state condition is reached. That means the values will not change with respect to time. After we ensure that steady state condition is reached, we will note down all the values in the observation table. Now I will be focusing on the observation table. You can see here, this is the observation table. This is the volt reading, ampere reading, this is the temperature reading. So likewise, you can set the dimer state to different voltage and different ampere reading will be coming, and you will do the same experiment at different voltage and ampere. So after filling this observation, we can find out what is the heat input, that is voltage into current. The area will be given. We can find out by getting the diameter and length of this. Then the average temperature, that is of the vertical cylinder. Then the ambient temperature you can find out. Then from the formula of Newton's law of cooling, we can find out what is the heat transfer coefficient. Okay. Now after taking the observation and after finishing your calculations or after taking all the readings, what you have to do is you have to ensure that your timer state is again rotated to 0, and you have to switch off this, and again you have to switch off this mains. Okay, thank you.